Hi, hello, welcome to another lesson in Math 2. We're talking about Lesson 3 of Unit 4. We're going to talk about the fundamental theorem of algebra today. So during this lesson, you're going to learn how to apply the fundamental theorem of algebra to quadratics. Okay. So the fundamental theorem of algebra states that every polynomial of degree n has exactly n roots or intercepts. We also think of these as solutions, right? Some roots may be real, some may be imaginary. We know solutions are where the polynomial crosses or touches the x-axis. Other names are root, x-intercept, and 0. A complex number is any number that can be written in the form of a plus bi, where a and b both can be 0. Alright, so our number systems. I have the real number system, which is a system of numbers that can be written as whole, decimal, fractions, or etc. We'll go over more detail in this, and I believe Unit 5. So the next unit. Okay. Now I want you to try. So are irrational numbers also real numbers? So let's look. Irrational, definitely still in the real number. So we would say yes. Our whole numbers are also rational numbers. Whole numbers, yep. So how this works is natural numbers are whole, integers, rational, and real. So it's kind of in size. It's kind of like a little Russian doll thing. So whole numbers are rational numbers. So I would say yes. Are all integers, are all integers also natural numbers? Integers, it doesn't go this way. So we would say that is definitely no. Are all natural numbers also whole numbers, integers, rational numbers, and real numbers? So natural numbers. Yes, so they're everything. They're the smallest little doll inside that Russian doll kit. Okay, so factor form of polynomials. Set each factor equal to 0 and solve for x to find the x-intercepts of the polynomials. Oh, so that's my zero product property, right? What that's saying is if any one of these things equals 0, when I multiply it by the others, they'll all be 0. So my multiplicity rule is the number of times it's associated with the root, root exists in a polynomial. This usually appears as the exponent of the factor. It also describes how the graph will touch or cross. So when we're talking about multiplicities, we're looking at the exponents of how many times is that root a solution. You'll learn in Math 3 kind of how that changes the look of the graph and how it touches or crosses the x-axis. But we look for that as the root. So if we look down here at the x-intercepts, I would say, okay, for this x minus r1, the r1, a positive r1, would be my root, and it would have a multiplicity of whatever that exponent is. If it was 2 times, it'd say multiplicity of 2. If it's at 4, saying how many times is that root a root? Okay, so finding multiplicity. Let's find the multiplicity and root of the following polynomial. Alright, so first of all, I'm just going to highlight the things that we can do. I can do this one. Right, x plus 3. That's the first one. I can do this one. X minus 4 squared. We can do this one. Good thing I have enough colors to do this. Goodness. And then lastly, that one. Okay, so if we look at this first one, I'm going to set 0 equal to x plus 3. We subtract 3 from both sides, and we get x equals negative 3. So that's my root. It has a multiplicity of 3. Okay, then we do this next one. X minus 4 equals 0. We add 4 to both sides. So I get x equals 4 with a multiplicity of 2. Do this green one. X minus 1 equals 0. I add 1 to both sides. I found that x equals 1 is my root. Has a multiplicity of 2. Next, let's do the shallow one. X plus 1 equals 0. I subtract 1. No, remember, I'm doing this right now where I'm setting each of these equal to 0. So I'm using the zero product property to see where my x-intercepts are, or where my roots are. X equals -1. Multiplicity of, wait, hold up, there's no exponent up here. If there's no exponent, it's just a 1 exponent. Okay? Okay, perfect. Now, where this is in factored form, if I asked you how many possible roots would that be, I would just add up all these multiplicities. So I'd say possible roots. I would say 3 plus 2 plus 2 plus 1, which would give me 3, 4, 5, 6, 7, 8. 8 possible roots. Okay? I want you to try find the multiplicity and the root of the following polynomial. So this one, okay, so pause the video, see what you can find. This one's a little tricky because this little x is hiding out front. So that tells me x can equal 0 with a multiplicity of 1. Little 1 up here, not written. Okay, for the next one, x plus 4 equals 0. We subtract 4 from each one. We get x equals -4. Multiplicity of 4. Then we get x minus 2. Oh. We get x minus 2 equals 0. I add 2 to both sides. So my root is 2 with a multiplicity of 2, so there's my answers. Okay, so fundamental theorem of algebra, so we kind of talked about this before, states that every polynomial of degree n has exactly n roots. Some roots may be real and some may be imaginary. The degree in the highest exponent of a polynomial in standard form and the sum of the exponents of the polynomial is in factored form. Okay, so what that's saying is if I'm in standard form, like I am right here, and I want to know how many possible roots I have, I just look at my biggest exponent. So this has 4 possible roots. If it's in factored form, we do like what we did here. We add up all the multiplicities, and that tells me how many possible things, how many possible roots or solutions I have. So let's look at this one. So this is how many real or imaginary roots does the following polynomial have. So right here, I'm just looking at my multiplicities here. So I have a 1 here, a 2 here, and a 5. So I go 1 plus 2 plus 5. And we're just taking these exponents, and that's where I'm finding these numbers from. 5, 6, 7, 8 possible roots. And this only works for factored form. If it's in standard form, and say we had x to the 4th plus 3x cubed plus x minus 7, I would just take my biggest exponent. And so I'd have 4 possible roots. You just have to decide which form it's in, standard or factored, to know if you have to add up the exponents or if you just take the biggest exponents. If you have any questions about this, please feel free to come talk to me, a tutor. We'd be happy to help you out. Have a great day. We'll talk to you later. Take it easy.